and though I'm coming after a long time, I was a little busy. So today I have a chapter for you on mensuration. It will have two parts. Part 1 will be concepts and basically the formulas, and part 2 will be questions and answers, right? So good news is that Scoremore would be sending you test series. We'll have 50 questions. So for class 8, it would be on February 24th. Okay, so you can just keep on studying hard and all the best, and wait for the test series to come. It will be maths and science, and it will be 50 questions, top questions, 50 questions for maths and science, and the date is February 24th. And also students, it will be a presentation, a PPT format, so you can just stop and you can click stop to see, and again we'll have answers as well. In maths there will be steps so that you solve on your own, but the steps will be mentioned to you, and there will be also answers. So that's for maths, and for science again 50 top questions. So that's February 24th. So I hope you all are keeping good care of yourself. Okay, so now let's get started. For mensuration, so these are the basic things for mensuration class 8. Square, so square, perimeter, area and volume. So basically it's a 2D figure. So here in perimeter is 4 into a, area is a square. So basically meter square or centimeter square, whatever unit is given to it is in square, and for perimeter it is meters or centimeters. So basically this is the formula. So for square 4a, again another figure, rhombus. Rhombus is basically the diagonals are bisecting each other at 90 degrees. So this is a rhombus. Rhombus again is just like a square, 4a, right? And so this is so perimeter for rhombus in square is 4a. Now we go to area. It is length into breadth for square. Sorry, side a square or side square is for square. So let's start for rhombus also now. For rhombus it is d1 and d2 are the diagonals. So half d1 into d2. This is the basically for the rhombus. So the multiplication, the product of the diagonals and half. Right? This is the for rhombus. So now let's go to rectangle. Rectangle is twice length plus breadth. Perimeter, and for area it is length into breadth. Again a 2D figure. So basically there is no height in this. Basically it's on one plane surface, it's length and breadth. So rectangle and square, length into breadth is the area of the rectangle. For triangle, if three sides ABC are given, perimeter is A plus B plus C. Perimeter is the sum of the sides, right? So what is the area then? Base into height, half. Half base into height is the area of the triangle, right? Now let's take a parallelogram. Parallelogram is the two sides are parallel, right? So this may be 4 centimeter, this may be 4 centimeter, this may be 3 centimeters. So but the sides are parallel, right? So for a parallelogram, what's the perimeter? This for perimeter for rectangle is twice length plus breadth. For this it is twice side 1 plus side 2. So side 1 is this, side 2 is this, right? Side 1, side 2. This is the side 1, and this is the side 2. So 2 times, because there are 2 times one side, 2 times second side. So 2 into side 1 plus side 2 perimeter. The important point is area. Area is base into height. So for now again we compare like we compared for square and rhombus. We will compare for area for parallelogram and triangle, because see there is a small relation. So this is the way to best to understand. For area of parallelogram is base into height, and for area of triangle is half base into height, right? So always make comparisons like this for parallelogram and triangle. We also compared for square and rhombus. For rhombus what we took? Product of the diagonals. Half into product of the diagonals, right? This is the area of the rhombus. And what else we compared? We also knew that side perimeter for rhombus and perimeter for square are same, 4 into a. Now trapezium. Now for trapezium, this is basically base 1 and this is the base 1, base 2. Bases, these are bases, they are different. They are different in centimeters, and this is the height between the base. So what is the formula? So when we make a trapezium, we will have different base, right? So base 1 plus base 2 will be added. Half base 1 plus base 2 into height. So what is the trapezium area? Area of the trapezium is, perimeter is not important in this. Trapezium's area is important. Base 1 plus base, you add the bases and half of the base 1 plus base 2 into height. Suppose this is 3 and this is 4. 3 plus, suppose this is 3 and this is 5. Suppose this is 5 centimeter and this is 3 centimeter. So it will be half 3 plus 5. Let's take some height as 4. I've taken height as 4 centimeters. So this is the formula. So half into 5 plus 3 is 8. This 4 into 4. So this is how much? 2 4s are 8. 4 into 4 16. Right, centimeter square. Okay. So this is how you do it. So this is, suppose this is the formula: base 3 centimeter, 5 centimeter, and 4 centimeter. Given half base 1 plus base 2 in brackets into height. For cube, now cube, cuboid, cylinder, these are 3D figures. 3D figures has length, breadth, and height as well. So 3-dimensional figures. For volume, you see, now we come to the volume part: centimeter cube or meter cube. What is 1 meter cube? What is 1 meter cube? What is 1 meter in centimeters? 1 meter is equal to 10 centimeters. 1 meter cube is 1 meter into 1 meter into 1 meter, which is 10 into 10 into 10 centimeter cube, which is 10 into 10 into 10 centimeters, so which is 1000 liters. So 1 meter cube can also be 1000 liters, right? So now we come to cube. Cube is basically like a dice is a cube. So all the sides are there are six faces. This is front, back, top, below, and sides. So basically this is a cube. Even in a dice you see top, bottom, sides, right? So in a cube what happens? When there is a top, there is a bottom, and there are 4 sides, right? So there are 6 sides basically. So for cube it is there are two things here in cylinder and cube. So one is the total surface area, which is the total surface area, and one is the lateral surface area. So lateral surface area for cube is 4a square. So herein area is important and volume is important in these 3 figures. Very important: cube, cuboid, and cylinder. Remember, total surface area is 6a square. 6 sides, 6 faces. Side A is the side, so 6a square. This is the area, total surface area. And what's the lateral surface area? 4a square, right? So just like we are not taking the top and the bottom, we are taking the 4 sides. So 4a square is the lateral surface area of the cube, and total surface area, the whole, is 6a square. So what is the volume of cube? A cube, side cube. Like we have side square in area. Now it is cube because it is length into breadth into height. All the sides are equal. A into a cube, or side cube. That's for cube. Now we go to cuboid. Cuboid, same way, has 2 things. Total surface. Cuboid. Okay, cuboid is just like a room. A room is like, you know, your room where you reside. It is in the form of 4 walls and ceiling, and there is a ceiling. There are 4 walls. There is ceiling, and there is a floor. So again 6 faces, and so basically like area of 4 walls. You know, if you take about area of 4 walls, then that is basically like a lateral surface area. So for cuboid, for cuboid surface area is 2 lengths, 2 breadths, and 2 heights. So twice length into breadth plus breadth into height plus h into L. What is the surface area? What is the surface area or the total surface area? Same thing. Surface area or total surface area for cuboid is 2 twice length into breadth, breadth into height, and height into length. So you see here 2 times h, 2 times length, and 2 times breadth, right? So twice brackets LB plus VH plus HL. HL is height into length. So this is the surface area of the cuboid. Now let's talk about the volume. Volume of the cuboid is length into breadth into height, like a matchbox. Matchbox is rectangular. It's a cuboid. Length into breadth into height. Okay, that's the volume. And so now you know about cuboid. Cuboid. Now we go to cylinder. Cylinder is like the LPG cylinder you have is a cylinder. They're basically two circles, one at the bottom, one at the top. So now we talk about again two things here: lateral surface area and total surface area. So for lateral surface area, it's 2 pi r h. 2 pi r, you remember, is what? Is the circumference on the perimeter of a circle into height. So this is how you remember, because cylinder is like this. This is like cylinder. This is the height of the cylinder, and this is circumference of the circle, which is 2 pi r. So 2 pi r into h is the lateral surface area of the cylinder. And when we talk about total surface area of the cylinder, it is what? 2 pi r square plus 2 pi r h. It is 2 pi r h, which is the lateral surface area, plus 2 pi r square. See, one circle and two circles. Pi r square is the area. Pi r square is 2 pi r square. Right? This is how you can remember. Pi r square and pi r square, 2 pi r square. So lateral surface area, which is 2 pi r h. Lateral surface area is 2 pi r h plus 2 pi r square. 2 pi r square. This is the total surface area of the cylinder. So you can write this in this form: 2 pi r bracket r plus h. So basically it is what? 2 pi r square. See, 2 pi r square plus 2 pi r h. 2 pi r h is lateral surface area of cylinder. So if the lateral surface area of cylinder is given to you, which is 2 pi r h, and radius is given to you, okay, then you can always calculate the total surface area, because when 2 pi r h is given, you can calculate the radius of the figure, right? So when the radius is when you can calculate the radius, then you can always calculate 2 pi r square also. So you can calculate total surface area. So in such questions, lateral surface area can be given to you, and radius you can calculate then, and then you can always calculate total surface area, because they might ask you total surface area. They will give you the lateral surface area. This kind of question can come, right? I hope cylinder is clear to you. Cylinder. Now we move further. Circle. So basically these are 2D figures: circle, semicircle. Circle. You know, circumference is 2 pi r. 2 into pi into r. So what is 2r is d. Sometimes diameter is given to you, so then it's pi d. 2r is diameter, so you can also take this as pi d. Perimeter is pi d, right? So, and herein we were talking about the area. Sorry, now we one more thing I missed. In cylinder, pi r square h is the volume. Pi r square h is the volume. So in cuboid, length into breadth into height, and in cylinder it is pi r square h. So what we discussed, 2 pi r h for cylinder and 2 pi r plus h. These are all areas of the cylinder. But when they ask you volume for cylinder, it is pi r square h. So basically this table is there, and you can always memorize this, right, and learn this and understand. So I am making you understand, right? So circle, very simple. 2 pi r, you know, from 6, 7, 8 you did this. 2 pi r is the circumference. So pi r square, you also know pi r square is area of the circle. And what is pi? Pi will be given to you is equal to 22 by 7 or 3.14. As for the question, you can use this. If there you see, if there is a 49 in radius, then you always use 22 by 7, because 49 and 7 will cut. So you have to apply your common sense. Students of class 8, how pi has to be taken, right? And so this is pi is this. So this is for circle. Volume is not there because it's 2D. Semicircle, again half of circle, which is half of 2 pi r. So this cuts, it's pi r, pi into r, right? So in such questions, they can be diameter given to you as 14, right? Radius will be 7 then. So what you will do in such questions? Will you use 3.14 or will you use pi? You will use pi in such questions, because pi is 22 by 7. 22 by 7 into 7 is equal to 22 centimeters. This is your semicircle. This practically explained to you when you will use pi. So, or maybe this it's already given to you in the question, so you can always apply your common sense. Pi will be then 7, 22. 7 gets cut. So this is pi r. Now quadrilateral. So quadrilateral is like, suppose this is a quadrilateral ABCD and there is a diagonal. From the diagonal, when you make a diagonal, there are two triangles which are being made. One triangle is ADC and one other triangle is ABC. On ABC, you have height H2, which is from the vertex B to the diagonal AC, which is H2. Again, on the diagonal AC, there is from the vertex D, there is a height H1, right? So this is basically perpendicular. So this is what happens now in quadrilateral. Remember, it is half into AC. See, AC is common here. So what is the area of triangle? Half base into height, half AC into H1. Half AC into H1 plus half AC into H2, which means AC is common, diagonal is common, H1 plus H2. This is the formula for quadrilateral. Area of quadrilateral is half into diagonal H1 plus H2. Half into diagonal H. Very important. Question can come from this. Question might come from this. And cylinder definitely is very important. You need to know at least the volume, pi r square h. And both these things are important. Lateral and total surface area. I already given an example how question can come. Lateral surface area will be given to you for cylinder and total surface area will be asked. And R has to be calculated because you already have 2 pi r h, right? So 2 pi r h is equal to, suppose given to you, and height will also be given to you. So you will calculate R first, and when you know R, then you can always put the formula for total surface area, which they will ask you, which is 2 pi r plus h, right? And that if you open this, it is 2 pi r square plus 2 pi r h. And I already explained to you pi r square and pi r square, 2 pi r square. And for lateral surface area is 2 pi r h. 2 pi r is circumference into height. This is the circumference of this circle. Right? So this is how. For cube. Now for cube it is, again for cube, might ask, trapezium is important. So trapezium is, see what's the difference in quadrilateral and this? This is the diagonal which is common. And herein, there's nothing common here. It is bases are being added, half of the bases b1 plus b2 into height, right? And herein it is h1 plus h2 and diagonal is the common. So this is the difference in when you calculate the area. These things are simple. Rectangle, definitely a perimeter can be asked, and for square again area will be asked. So these questions are important, which I am marking for you. Cube, yes, 6a square is important. Total surface area of the cube can be asked. So anyway, I will discuss some important questions now. This is the chapter part 1, which was all about concepts, and these are the important concepts, and you can just have a look at the board one more time. And these are the important questions and concepts which are important. Another video will come to you on questions and answers. Till then, you all have a great time. Enjoy and be happy. Bye.